Let's talk about orbitals and orbital diagrams. So what are you supposed to know? Number one, an orbital is just a region within a shell where there's a high probability of finding electrons. Orbitals are going to be assigned letters S, P, D, let's say an F. So these will be like the orbitals. Now the S orbital itself, how is it? So let's say this is our axis and that is our axis, like that. So for the S orbital you only have a round. Okay, it's very round, so the entire orbital is able to accommodate about 2 electrons, so it's round like that. So that is our S orbital. Now moving on to the P orbital. How is our P orbital? So if we are going to draw our axis, so for a P orbital it's a dumbbell. Okay, so a dumbbell going like that and another one going like that. So basically that is a P orbital, and the entire orbital is able to hold 2 electrons. However, you know, it has other smaller orbitals like the Y, the X and the Z. Okay, each of them at least they are going to accommodate 2 electrons. That's how it should be. Okay, that is also very important. Then what about the D orbital? So when you have 2 dumbbells instead of 1, you're going to have the D orbital. Okay, if I'm going to show my dumbbells, let's say this is the first one going like that, the second one going like that. Then let me draw another one in that direction and another one in that direction. Okay, basically this. So that is going to be our D orbital, 2 dumbbells. Now there's also an F orbital. Now for an F orbital you're going to have a lot of dumbbells, not just one but several of them. So you can have one, you know, in this direction, you can have another one, you can have another one there, you can have another one, like a lot of them. Basically that. Okay, that's just an illustration of an F orbital. Now there are also what we call orbital diagrams. Now an orbital diagram, at least for it, is it's just another way of showing how electrons are distributed in an atom. So however, an orbital diagram, what you should know is that it's a bit more specific than the electronic configuration that we usually show. Now there are 3 rules that you're supposed to know before we start drawing orbital diagrams. Number 1 is what we call the Aufbau's principle. Now what about the Aufbau's principle? So according to the Aufbau's principle, electrons feel the lowest energy levels first before moving to the next energy level. That is very important. So you feel the 1s first before going to the 2s, before going to the 3s. So basically that's how you are going to move. You feel the 1s, go to the 2s, then you go to the 3s, not to the 3s, to the 2p actually, 2p. Okay, like that. That's how you feel the electrons. So that's the Aufbau's principle. Then another principle is called the Hundi's rule. Now according to Hundi's rule, each orbital receives 1 electron before doubling up in an orbital, before adding a second electron. Okay, why? Because electrons usually repel each other. Let's say this is a P orbital. Okay, let's say this is 2p. Now you are going to have x, y and z. Now if you have XYZ, you fill electrons first singly, okay, before doubling them. Okay, so what this means is you're not first going to put electrons in X. No, if there are two, you're going to put the other one in, because if you put them here, electrons are negatively charged, and you know, according to the rule of charges, like tend to, you know, repel each other. So they're going to repel each other, so they'll prefer to go in this other orbital. So consider orbital as rooms. So if there's one room that is empty, and let's say you've moved in a house, and in this house you've got one room, okay, then there's an extension of another room, so your friend would rather go in the next room than you guys occupying the same space in one room when another room is empty. So that is the Hundi's rule. Then rule number 3, you can also consider what we call the Pauli's exclusion principle. So according to the Pauli's exclusion principle, electrons have opposite spin, okay. So what that means that you're going to be showing up and down arrows, okay. So if, let me say this is an orbital, so one is going to go up, the other one is going to point it down. Basically that's how you know, show electrons. Let's draw maybe one of an example. Let's pick oxygen. So you know that oxygen has about 8 electrons. So if it has got 8 electrons, if we're going to draw, let's say, the orbital diagrams, how are they going to look? Let's say this is the first one, this is the first orbital, the second orbital, let's say this is the third orbital, the p orbital. So what are we going to have? You know that the electronic configuration, we say, doesn't really provide the most specific, but at least it shows something. So you have 1s2, you have 2s2, the s is done, you go to 2p, 4. Basically that's how it's going to be. But now how are you going to fill these electrons? So let's say this is the 1s, this is the 2s, this is the 2p, okay. But now this, let's say this is x, this is y, this is z. Okay, now how are we going to now fill these ones? So the 1s is going to get the first and the second electrons, so it's just going to get them like that. That is the 1s. You always fill the 1s first, okay. Then you go to the second one. Now the second one also is able to accommodate 2, so you put 2. These ones are filled. Now we are remaining with 4 electrons. These 4 electrons, how are we going to now put them? So according to Hundi's rule, like we've said, you're putting one by one in each orbital. So put 1. I'm going to put 1. Then we've remained with another electron, so I'm going to put it here. So this is how you're going to show oxygen in terms of orbital diagrams. However, it would be wrong if you had to put them like this, then you put the other one like this. What about this room? So basically that does not agree with Hundi's rule. So this is what you're supposed to do. So this is all that we can talk about orbital diagrams. Thank you, and see you in other sessions.